and let us discuss about this only again. That means about collisions only we are going to learn today. And colliding bodies comes to stand still or rebounding back. Bouncing back. That means two objects are there. Now see here. Now we are taking again one system, and in that system, how many objects are there? Sorry, two objects are there. This is M1 object, and one more object is there, which is M2 object. So two objects are there, right? So these two objects are moving with some velocity, and before collision, how much momentum will be there? After collision, how much momentum will be there? Those things we are going to discuss, and we are going to understand whether the law of conservation of linear momentum will be valid here or not. And to understand, here they given one particular condition here. When two balls of same mass m and speeds v meter per second are moving towards each other, then the total momentum is zero. Whether it is right or wrong, let us try to understand. Now here again I am drawing. Two balls are there. First ball is having a mass of m. Second ball is also having a mass of m. And first ball is moving with a velocity v in one direction, and at the same time second object is moving in opposite direction to this. Where it was given, these two are moving in opposite direction, moving towards each other. Moving towards each other means what? They are moving opposite to each other. And when they are moving opposite to each other, what will be the total momentum before collision? So to find out total collision before momentum, maybe you know that we have to use one equation, which is nothing but m1 u1 plus m2 u2. And what is m1 here? Mass of a first object is m. And what is the velocity of the first object? V. And now here I am writing, instead of plus I am writing minus. Why minus? I will say you now. So mass of a second object is also v, and velocity of a second object is also v, but it is moving in a negative opposite direction. That's why I'm taking it as minus v. So now if I add both, how much you will get? 0 you'll get. Will you get 0 or not? Will you get 0 or not here? Arnav? Arnav?
Yes, sir.
Right. Have you understood here? M1 U1 plus M2 U2 is equal to 0 is coming. How 0 is coming? Two objects are there. This is first ball and this is second ball. Both are having same mass. Both are coming to each other. Coming to each other means if I take velocity of the first object as positive, velocity of the second object will be negative. Why I have to write minus? Because velocity is a vector. Do you know what is a vector?
Yes, sir.
What do you mean by vector?
Sir, physical quantities having magnitude as well as direction.
Very good. When direction is there, to specify the direction opposite, we have to write minus or not? We have to write minus or not? Sahas. Minus will tell us about what? Minus will tell us about what? Sahas, are you listening? Sahas, fast. Are you listening or not? Whether he is there? Okay. Right. Tell me, Arnav, whether it is right or wrong. The momentum of a initial momentum of a system is constant, sorry, 0. Whether it is right or wrong. Now tell me. Right. Tell me message, Bhumika, whether you are listening me. Milan, you are listening me. Milan, right. Can you speak, Milan? Can you speak? Right. Sahas not there. Okay. Right. Tell me whether this momentum now before collision will be 0, right or wrong. Milan, Bhumika, everyone. Why will not be 0? Bhumika, why will not be 0? Now here only I wrote already. What I wrote here? Mass of first object is m. Velocity of a first object is v. And initially mass of a second object is also m, and it is moving in opposite direction. So as it is moving in opposite direction, definitely velocity will be minus v. So now I am adding m1 u1 plus m2 u2. That means right. That means initial momentum of a first object is mv. Initial momentum of a second object will be minus mv. So I am adding both. When I add both, they will be cancelled with each other or not. And when they are cancelling with each other, what you will get? Total momentum before the collision will be zero. And see here, what we are discussing actually, we are discussing about colliding bodies come to a standstill or rebounding back. For that, we are learning about all this. Okay, colliding bodies must come to a standstill. That means they have to stop there. And rebounding back, that means they are moving away from each other. So then whether law of conservation of momentum will be valid or not. So that's what we are going to test here. And in that test, we got uh, the initial linear momentum of the system as zero. So this is what you have to understand in this case. Right, Bhumika, is it clear now? No, you also can't speak now. Okay, little bit my voice is echoing because I'm using both the laptop and this mobile. So that's why. Actually, I can't see your messages. So therefore only I'm using this mobile because you are getting, sorry, that's why only you are getting echo. Right. Whether my audio is clear now without echoing or you are listening echo of me.
Sir, a little bit.
Little bit echoing is there.
Yes, sir.
Right. So to observe you people, I'm using this mobile for some time. Nothing will happen. So you can hear the sound clearly. So
Excuse
now
me, sir.
let me explain. Tell me.
Sir, you can turn your mobile volume down.
That only I did. Even then, it is there like that. I can't make it complete zero, but some voice is remaining there. Even though I
Sir,
pressed
you
again,
can leave the audio.
I muted that also. Even though I mute it, you are getting this particular echo. Why I don't know. Right. So it is for only message purpose. I opened it. Right. Now colliding bodies comes to standstill or rebounding back. So in that case, you are learning about before collision how much momentum will be there for a system. After collision, how much momentum will be there for a system. And before collision, total momentum of the system will be zero. That already you learned. But now let us try to understand how many possibilities are there in such a way that the law of conservation of momentum will be valid. And though there are two possibilities here, and those two possibilities are nothing but what? First, first possibility is both the balls must come to rest after the collision. That means before collision, objects are moving like this. Observe. M first object is moving with a velocity v, and this is second object move same mass but moving in a opposite direction, that means with a minus v, and they collided, and after collision they stopped here only. So here mass, here also mass. Now what will be the final momentum here? Now final momentum of a first object is zero. Why? Because velocity is zero as they are coming to rest. And second object velocity is also zero. These are actually u, initial velocity of the first object, initial velocity of the second object. This is u1 and this is u2, and this is v1 and v2. And maybe you know that for a final total momentum of a system, generally we have to write like this: m1 v1 plus m2 v2. So m1 v1 is nothing but 0. Why? Because v1 will be 0 plus m2 v2. v2 is also 0, 0. So now what will be the total momentum after collision? Total momentum after collision is also 0. How much initial momentum is there? Total initial momentum is there for the system? 0. Already we observed it in earlier case. Now for a first possibility, whether the law of conservation of momentum is right or wrong. Arnav, tell me whether law of conservation of momentum is right for this particular first case or not. Arnav, are you there?
No, sir.
Why it will not be conserved?
Sir, the ball will not come to rest, sir. It will be conserved.
Huh. If ball comes to rest, both balls are coming to rest. Whether law of conservation of momentum will be valid now or not.
No, sir.
Hmm?
No, sir, it will not be valid.
Why?
Sir, they should
Before collision,
rebounce back.
uh-huh. Before collision, how much momentum is there? Before collision, how much momentum is there? Already I wrote here. What is
Yes,
the
sir.
total momentum of a system now before collision?
M1 U1 plus M2 U2.
And how much is given? Already we calculated, no, that value. That value turns out to be zero here, no?
Yes, sir.
Right. That means initial momentum of a total system will be zero or not here.
No, sir.
Why it is not zero? Already I calculated, no, here. M1 U1 plus M2 U2. That only I substituted here and found the value. And that value turns out to be zero. Why it turns out to be zero? Observe carefully. Two balls of same mass with the same velocity moving in opposite direction. So that's why initial momentum became zero, isn't it? Have you understood now or no at least?
Yes, sir.
Right. So Bhumika given what she given zero. How it is zero before momentum, before collision? As both the objects are moving in opposite direction with the same velocity, that's why momentum of one object will be cancelled with the momentum of a second object, and thereby the total net value will become zero. So before the collision, total initial momentum will be zero. Now what is final momentum after the collision if both the balls are coming and stopping here like this? Definitely, the momentum of the system will be zero again as they are not moving at all. After coming and hitting, they are still like this. So that means law of conservation of momentum will be valid. Why it is valid? Before the collision, how much total momentum is there? After the collision also, same momentum is there. Before collision zero, after collision also zero. So that's why law of conservation of momentum will be valid in first case. That means when both the objects are in a rest after collision. Now let us try to understand about second possibility. And what is that second possibility? Both the balls are moving away from each other. Now in this second condition we have to understand like this. Now after collision, now this object is moving in this direction and this object is moving in this direction. Rebouncing back means uh, both the balls are moving in opposite direction. Now mass of this particular object is m, mass of this object is v. If I am treating whatever the object which is moving in a right side, if its velocity I am treating it as plus v, then definitely the object which is moving in opposite direction will be minus v. So both balls are moving away from each other with the same velocity. And when both the balls are moving away from each other with the same velocity, then if I calculate final momentum by using this equation, m1 v1 plus m2 v2. If I use this equation, see here, m1 means mass of the first object m, and what is the v1? That means final velocity of the first object minus v. So that's why I'm writing here minus v plus m2 means mass of the second object m. v2 means what? Velocity of the second object, final velocity of the second object, and that too will be v here. So minus mv plus mv now will become 0. Now also total momentum of the system will be 0. But try to understand, repouncing back means they are moving with the same velocity. Then only you have to say rebouncing. And if they are moving away from each other with a different velocities, you will not say rebouncing, or you will say like this, rebouncing with a different velocity. But here they are saying that they are rebouncing with a same velocity. When they are rebouncing with the same velocity, definitely the final momentum will become zero. So as the final momentum is becoming zero here, that means in this case also, in the second case also, law of conservation of momentum will be valid. So you have to understand like this. Before collision, how much momentum is there? After collision also, same momentum must be there. Before collision, if zero momentum is there, after collision also zero momentum must be there. Then only you say law of conservation of momentum is valid. Otherwise, law of conservation of momentum is not valid. So to have a law of conservation of momentum to be valid, these two cases will happen when two objects of same mass are moving with a same velocity and approaching each other. So this is what you have to understand in brief, but this is also an application of a collisions only. So you are learning about collisions by taking Newton's third law of motion. Okay. Bhumika, is it clear now? Right. Arnav, maybe I hope you understood. Is it clear, Arnav?
Yes, sir.
Right. What about Sahas? Are you following me? Sahas? Milan, is it clear for you? Milan, type at least whether is it clear or not. Are you listening, Milan? What about Sahas? Sahas is there or not?
Yes, sir.
Right.
Yes, sir. I understood.
Is it clear now?
Yes, sir.
Right. Okay.